Aloha and welcome. In this video, we're going to be talking about symmetric encryption. Particularly, we're going to be talking about the stream cipher. You'll remember symmetric encryption. We talked about it before. Symmetric encryption is an encryption algorithm that uses the same key to encrypt and decrypt the data. So you're going to be using a symmetric key or a secret key, and that's going to be used through your symmetric encryption. It's different from asymmetric because asymmetric encryption requires one key to do the encrypting and another key to do the decrypting. So within symmetric encryption, though, that uses the one key, we've got two different types of algorithms here. So we've got stream cipher and we've got block cipher. So the difference between these two is a stream cipher is a symmetric encryption algorithm that's going to go one bit of data at a time. So a 0 or 1, then the next 0 or 1, then the next 0 or 1. So if you think about, you've got a character like A is going to be 1 byte. A byte is 8 bits. So you break that up into 8 bits, and you're going to process that one bit at a time. The other side of it is the other type, you've got a block cipher. And a block cipher is a symmetric encryption algorithm that encrypts a whole data block at one time. So some of them are like 64-bit data blocks. We'll talk about that later. But you'll do a whole block at a time. So uh, one of the reasons why we use symmetric encryption is because it's faster. It's more efficient than asymmetric encryption, since the symmetric encryption uses shorter keys, also has simpler operations. And we're going to talk about that. I've got some notes for you on the XOR operation. The XOR operation is one type of operation that's done for this type of stream cipher encryption. It's pretty cool. XOR is basically asking, are the two bits you're comparing different? If they're different, you're going to get a 1. So let's say you have a 0 and you have a 1. If you have two things that are different, it's going to come out to 1. If they're the same, it comes out to a 0. So 1 and a 1 is going to be 0, a 0 and a 0, 0. A 0 and a 1 or a 1 and a 0 will give you a 1. So that's how the operation works. But hidden in it is a secret property. And I want you to read our notes to see what that secret property is. And it has to do with how you're going to encrypt and decrypt. So take a look at that. It's pretty neat stuff. So symmetric encryption, it's used in many of the cryptographic protocols out there, such as HTTPS, which gives you safe access to websites, as well as IPsec, which is used for IPsec tunnels and such. So let's go ahead and open up our textbook. So we've gone through a lot of this material. Go ahead and try that out. In talking about stream ciphers here, we mentioned that stream ciphers are going to encrypt your data one bit at a time. So in order to do that, you take your encryption key and you're going to convert that into a key stream. And what is a key stream? A key stream is a continuous bit stream. So it's, a stream of zeros and ones, just a big long stream of it. So how do you make that key stream out of your encryption key? Well, use something called a key stream generator. So a key stream generator, it's an algorithm that essentially makes that key stream out of your encryption key. So this key stream generator and the key, they're both held at the data sender and at the receiver end. So you both have it. So the data sender and the receiver use the same key and key stream generator to encrypt and decrypt the data. So then moving on, stream cipher is computationally efficient because the encryption and decryption consist of a simple operation, such as an exclusive OR, what we call an XOR. Since the stream cipher encrypts data one bit at a time, an error in encryption does not propagate. In other words, if you mess up, let's say something happens, there's a glitch in the system for some reason, a 0 gets flipped to a 1 when it shouldn't have been, that error exists only in that one place. It's not going to propagate later on down the line. When we talk about block ciphers and things like that, sometimes you're XORing your first plain text sheet with the next one. And if you have a problem with the first one, you're also going to have problems with every single one after that. So these are different. So a stream cipher, essentially, if you have an error in transmission or whatever, it's only that one that's affected. It doesn't affect anything that comes later. Just keep that in mind. So your stream cipher here, it's going to not propagate errors if you should have any errors. So stream ciphers are commonly used in communication applications that require fast encryption or decryption of the data stream. And an example of that is A5/1. and that's one that's used for encrypting the data that's exchanged between a mobile phone and a base station. And down here, we've got a nice example of the process of turning that encryption key using a keystream generator into a keystream. Then that keystream is fed into this XOR operation. So you crank one bit in, then you take one bit of the plain text, and that comes out with a value here. And then you crank in another one on both ends, push this over, and you put your character down there. So that's how the stream cipher is going to work. So we've got some exercises here for you to do, and that's it pretty much. But I want you to check out our notes that we made on this chapter. I went ahead and wrote up the study notes here in our shared document, and I put in some really good explanation of XOR, so you'll understand that a little bit better. So if you have any questions, feel free to reach out. I'm happy to answer. Have a great day. Aloha.